Hello all, welcome to the video lecture series for the subject Database Management System. This is a part 2 version of the previous video, that is a continuous video for the normalization in database management system. Now I am going to explain you all about what is boycott normal form, right? Basically, this is a normal form which continuation of 2NF and 3NF may allow anomalies in a functional dependency, right, which exists wherever the determinants is not a super key. But here bcnf handle edge cases where 3NF fails to remove all the redundancy, especially in the tables with multiple candidate keys. Now we are going to prove that with an example. So here you can see it is an advanced version of 3NF, right? bcnf is an advanced version which comparing with 3NF, and also it ensures that for every functional dependency. Now we are going to check what are all the rules for this functional dependency here. Rule number one, table should be in 3NF. I already told you, which makes the database design most robust and easier to maintain over a time. That is the reason the table should be in 3NF. And X should be a super key. Any of the column in a particular table should be, you need to select that as a super key for every functional dependency. Say for example, this is the random table I have selected. Now I am going to include one more super key which exactly to be prevented or else to be added over in this existing table. Say for example, there is a student column, teacher column and subject column. Now you can see which column depends on which column. More than one column depends on another column. That is called as multi-value dependency, that we have already avoided. Now we are going to see the functional dependency, right? Now say for example, teacher column depends on student column and subject column is also depends on student column. But we cannot have this student column as a super key because this column will have repeated number of names. We cannot expect this particular thing. For example, you can see there is 2 Vino in a particular class and also 2 Vinny in a particular class, but the teachers are different. Okay, the subject is also different. So this particular student column cannot be a super key. But one example we can give, we need to create a roll number for the student column. So say for example, roll number can be created for the super column. For example, 1, 2, 3, 4. So 1 is belong to this Vino and 2 is belong to this Vinny. Now abundantly we can able to reduce this particular thing. Now if you are going to map this, if you are going to just map this, you can able to see this student column can depends on roll number and this roll number can be a super key. I hope you understood. Now we are going to divide that into 2 different forms, right? Say for example, we have divided that particular thing into A1 and A2, 2 different table, right? This is actually not in a bcnf. We are going to make that into bcnf by creating a roll number, right? Now listen here. Now there is a teacher here and subject. Now here we have a super key as a teacher because we are not going to make this redundant values here. Now there is a subject called database C is repeated twice here, subject. Now this column is dependent on the teacher, right? There might be multiple teacher can teach the same subject, but here the case is different. Now the subject is database C, but the faculty who is handling that C is different and faculty who is handling that database is also different. Now the scenario is different here, so this teacher column can be a super key, right? If you want to avoid super key here, then you need to create a teacher ID here, right? So if there is a repetition, we can create a teacher ID here and that teacher ID can be taken as a super key. So the super key, the subject will be depends on super key, that is teacher ID, not the teacher, right? Now listen, we have created one more table here as A2, that you can check it. There is a teacher here and there is a student here. This is called as functional dependency. If the number of students increases here, you can see Vino can read database and see, right? But the faculty is different, but the students are same, right? Vino can have 6 different subjects. So we know that the student column will be repeated for 6 different subject, and 6 times we know will be repeated. And but in this case, teacher cannot be repeated. Teacher can be only one, right? Vinod is taking a teacher Das, Vinod is taking a teacher Ram, and Vinny is taking a teacher Das, and Vinny is taking a teacher Gupta. Right here you can see Das is repeated twice, and this Das is not taking different subject. They are taking the same subject for these two people, Vino and Vinny. Right? So in order to avoid, there is a functional dependency here, but there is no super key here. If we need to include a super key, then this table can be dropped. Okay, so this is actually called a functional dependency. If we want to reduce this functional dependency, then we need to adopt third normalization form, right? So X should be a super key. There's some column should be a super key for every functional dependency, right? So here the functional dependency, we can see that is a teacher, but here there is no functional dependency, right? I hope you understood how this bcnf is actually working in normalization form. Let me take you to the fourth normalization form, right? So let's check. It is a very simple way of understanding the fourth normalization form, right? Let me tell you what exactly this fourth normalization form table looks like. A table is said to be a fourth normalization form when we need to adopt every single process. There should not be any multi-value dependency, right? There should be a proper normalization form, which is important to reduce the redundancy here. Let me tell you. So here the level of database normalization where no non-trivial multi-value dependency other than a candidate key. For example, now we have taken 4NF is a higher level of normalization in relational database design, which deals with multi-value dependency, that is MVDs, right? So now we have taken one example, that is before 4NF and after 4NF. Now you can able to see there is a course here, and there is a teacher and the books which is referred for this particular course, right? So the course are AI, ML, network and compiler design. The teachers are different here, not the same. X, Y, Z, A. And also the books is also different. Peter, Churchill, Weston and Gilbert. So there is no repeated values in this particular column. There is no redundancy here, but there is a multi-value dependency. I hope you can able to see. See, the teacher is dependent on this course and the books are dependent on this course. So there is more than one column is dependent on this particular course. How to avoid this multi-value dependency, right? This is before 4NF. Now you can able to see I have created a two different table here. This is after, right? So what I did is I made this more than one column dependent on another column. So I made that into only one dependency. Now you can see here course and teacher is created in a different table, and one more table called course and book has been created. Now we have only one dependency here. Now the teacher is dependent on the course, that is X is with AI, Y is with ML, Z is with networks and A is with compiler design, right? So here teacher column absolutely depends on course, right? It depends on course only. Now there is more than one column is not dependent, only one column is dependent. So what we did, we avoided multi-value dependency here, right? So let's check this one more column here. You can check this one more column, that is course and book. Okay, now this book column is dependent on this course column, right? So AI is Peter, ML is Churchill, network is Weston, CD is Gilbert, right? So there is no one more column is here to depend on this course. So what we did exactly here, that is we have avoided multi-value dependency. What is exactly points on? 4NF is a higher level of normalization in relational database design, which deals with multi-value dependency. After dealing with this multi-value dependency, after seeing this table before and after, we are absolutely removed this multi-value dependency, right? So let me take you to the last normalization form, that is 5NF, fifth normalization form. What exactly ensures here, right? You are going to see some what is it, like advanced form of here, right? A table is said to be a 5NF if it is already in 4NF. That's the first point, right? It should be already in, that should not be any multi-value dependency, and it cannot be broken down into smaller table without losing a data. We are not going to lose any data here to be a 5NF. Let's see how exactly it works. It ensures that there will be no redundancy present in the data. It should be in 4NF, right? And it should be in BNF also. No multi-value dependency. Let's check this. This is a challenge for us here. How we are going to, without losing a data, right? And we need to convert that into BNF, and that should be in 4NF also, right? Now you can see I have taken this student table, student, teacher, and year, right? Let's take this as student table, right? So now you can see there is a subject column here, teacher column here, year column here. In subject, there is a repetition, that is C and C. And also in year, there is a repetition, that is first and second. In teacher column, you can see there is no repetition, right? Now we are going to make this particular table, student table, into 3 different table, right? Now why we are going to make that? Why? Because there is a dependency here. What is the dependency? Subject is teacher is depends on subject, and year is also depend on subject. That is multi-value dependency, right? First thing, we need to remove this, right? That is BNF. It should be in BNF. So what is BNF? There should not be any multi-value dependency. We are going to remove that. Now you can check it. Table number 1 tells you subject names are displayed, teachers are displayed. So there is more than one column is not dependent. Only teacher is dependent on subject, right? You can able to see here teacher is dependent on subject and year is also dependent on subject, right? So now we have removed here. What is the first thing we did in table number 1? We removed this multi-value dependency. Only one column here, teacher is dependent on subject, right? Table number 2, here there is a repetition, right? Now what we did is, here this year is also depend on teacher, right? Year is depend on subject as well as teacher. So what we did is, we removed that particular multi-value dependency here, MVDs. That is, we have created a one more table, so we should not lose any data here. That is the point. So there is a teacher and year. Now here you can check it. That is, year is depends on teacher first, second, and third, 2 times here, but teachers are, there is no repetition here, right? So multi-value dependencies are exactly removed here. The last table tells you about there is no redundancy present in the database. Now you can see subject is repeated twice here, and here is also repeated twice here. You can able to check subject twice, here twice. Now the third table is going to check subject has been removed. C is given for first, and AI is for second year, and ML is for third year. Only this part we are going to lose, only teacher table, because you can check it here. C has been taken by 2 different teachers for the same year, but here that is subject is not loosed, but the teacher is loosed. Now we have the joint dependency here. Okay, so I hope you can able to understand how this 5th normalization form is exactly working. We ensured there is no repetition here, and also we ensured there is no functional dependency here, right? I hope you understood this video to make you understand about all the normalization form in normalization in database management system. Thank you.